and you guys can't resist talking to each other. Talk to each other. If you have 2/5 of something, now if you don't know how to walk your way through that, ask each other, how many halves do you need for a whole? How many thirds? How many fourths? But then if it's not just a 1 in the numerator, how do we deal with that? And what do we need every single day in math? Graph paper. So if you don't have graph paper, get it. If you don't have graph paper, get some out. If you do not have graph paper, Sam, get some out. If you'd like to jot this down to help you, so like again, I don't control you, you control you, but if you want to jot this down to help you, I've got some examples here that we're going to talk through and like how can we figure it out? What do we need to do? But of course, I know, you were gone for a week, you missed it, you were yearning, you just wanted the randomness in your life. Random cards.
Oh, I meant free pies.
Free pie, that's done and over with.
That was a good pie.
I did have 2 pies left over that I took home. I ate one. I don't know what you guys have against pecan pie. Pecan pie is delicious.
Oh, at Phoenix Fair, I'm going to sell pies and pecan pie.
Well, remember, it's Phoenix Craft Fair, not just Snack Fair. If there's too many people selling snacks, it doesn't go very well. Raiden, if half of X is 8, or we could think of it, if you think about everything like pizza, like me, if half of the pizza would cost $8, how do we figure out what the whole thing is? We times it by 2, Raiden says. So if we multiply by 2 on both sides, that gives us that X is, what'd you say? All right. I really need to just take these with me. Emery, what about if we know a third of X is 10? What do we need to do there?
Oh, I don't know.
Yeah, you do. If you have a third of something,
Was it
how do
3?
you get to a whole?
Is it 3? Oh, no.
Kate Garrison, please come to the Perry
Lane,
office.
what do you think? We have a third of something. What do I do with a third to form it into a whole? Multiply by 3. Because if you have a third, you triple it. 3/3 will give you the whole thing. And what would X be there? 30. Because you've got to make sure you do it on both sides. Zane, what about if I have a fourth of something? We can multiply by 4. My cards are getting all messed up in my pocket.
I hate when that happens.
So 7 times 4, guys, there is no shame in counting on your fingers. You know what there is shame in? Having to get a calculator for every single math you do. 7, 14, 21, 28. If you don't know 7 times 4, count it up. Alright, so actually, now the other way around. Carolina, if I have 2x equals 40, how could I figure out x? We could divide by 2. And 40 divided by 2, there x turns into... And guys, this also is a reminder, there's not a value for x. We keep using x over and over and over again. Those of you who are not writing anything down right now, that's a choice you're going to live with. Here's where it gets real, of like, we haven't seen this before, and it might be tricky. Jane, do you got any ideas of what to do with 2/3 x? So what did we do when it was just like a third x? We times it by 3. I need everybody's eyes up here, probably both of them. If your eyes are going different directions, that's not a good thing. This is division by 3. This is division by 3. So with the division by 3, Jane said, well, we should probably multiply by 3. Sophie? Why? It's on your paper if you look down at your paper. In the middle, right below. below that?
Multiply the reciprocal.
This is a reciprocal because you're doing you're flipping it, right? My nickname is refliprical. Reciprocal, refliprical. All we're doing is flipping the fraction because, guys, look up here. Look up here. I know we're Monday back from break, but we got to do some actual math today. If you have 2 times something, we divide by 2 to undo it. This is 2 times. The 2 on top is multiplication. The 3 on bottom is division. So what's happening here is both multiply and divide. So we do both, multiply and divide to undo it. So over here, and this is what would be really good to write down on your paper, if you had A over B times X. A and B are numbers, right? A over B times X. What could we do to get back to just 1X? How do I deal with the A that's on top that is multiplying? We're going to put an A on bottom. What do I do to deal with the B that's on bottom right now?
Put B on top.
Put a B on top. And if I do it on one side, I got to do it on the... And guys, a number, any number can become a fraction if you just put it over 1. So take the fraction you've got, flip it, and it'll destroy things. We're going to do a couple examples to look at why. Linda's on a trip. She's got 2 different visualizations, but what she could write for this is that 2/5 of the trip, 2/5 of the trip, you can call the trip X, is how far? 100, right? Talk with your partner about how can we solve that. How can we figure out X? If 2/5 is 100, how can we get to what the whole trip is? Chat with each other. Make sure we write that we have 2/5 X. You're missing that X in there because that's what we're trying to figure out. Lane, my only concern is that you don't have a partner, so feel free to move if you want someone to talk to. Feel free to get with somebody else. Guys, you could write this on your homework paper and also on your graph paper if you want. Have a couple examples to reference. Eli, if I have 2/5 of X, how could I get back to 1 whole X? Okay, you can pass. Ashley, if I have 2/5 X. Yeah! We want to get rid of this division by 5. Ashley says to do that, we're going to multiply by 5. And we can, at the same time, deal with the fact there's a 2 multiplying on top and divide by 2. So essentially, we're setting up the fraction 5/2. But I love how Ashley said it. We're dividing by 2, and we're multiplying by 5 at the same time. Now, to make your life easier, how can I make 100 into a fraction?
100 over 1.
Put it over 1. Guys, we should be writing this on our paper, because otherwise, what's the point? Guys, what's 5 times 2? What's 2 times 5?
10.
What would 10 over 10 be?
1.
That's why we did what we did. The reason we use the reciprocal is it's going to end up giving us the same number on top and bottom. So we really just have 1x Okay, let's do the multiplication over here. Look up here, because I know we're still getting comfortable with this. We do top times top, bottom times bottom. What's 100 times 5?
500.
What's 1 times 2?
2.
Well, that's not that difficult. You guys are too good for that. 500 over 2. What is that?
250.
Oh, 250. I don't have another way that you kind of like visually looked at any of this and you're like, oh, well, I can just kind of reason through this. Sophie? So I'm still using cards, but.
So we kind of did it a little bit of a different way.
I bet you did it the same way.
Yeah, we might have like just.
You just did it in a different order, but say it.
Okay, so using the number line thing, so since we have 3/5 missing, and we know what 2/5 is, which is 100, and so now we have 200, and we have 4/5, so now we only have 1/5 missing.
So wait, so you said we have this is another 100.
Yeah.
Okay.
And then, so now we only have 1/5 missing, and since 1/5 is half of 2/5, it would be half of 100.
Alright.
50. And then you add it all up, and it's 250.
Absolutely.
Yay.
Now wait, so you took your 100, you doubled it, and then you did another half?
Yeah.
Right, so you did doubled it another half. Hey guys, what's 5 halves? What's another way to say 5 halves? If I have 5 halves of pizzas.
2, 1, 2. Wait.
5 halves is 2
whole
and a half.
Half.
It's 2 and a half.
Oh.
What did Sophie do?
2 and
She
a
did
half.
2 and a half. This is 2 and a half. It's what Sophie did. Just kind of different because math has options. Guys, it's the same. It's all the same. Is the next problem? No, it's on your paper though, right? Yeah, 2. So you've got some space to show some of that work. Right, and it like repeats the same question multiple times. Now, if we were to look at this with like shapes, right, because we're doing a lot of geometry now. If I'm using 2/5 going this way, multiplying, of course, because they're showing it to us. Now, we're still multiplying, We've been used to like, oh, if I multiply this way, I divide the other way. But wait a minute, they're saying we're still going to multiply. But now we're going the opposite direction. Instead of multiplying by 2/5, what would we be multiplying by here?
5 over 2.
5 over 2. Guys, the other way we can use reciprocals is if you're going the opposite direction, instead of multiply versus divide, which you could divide. So hold on. We just said we're allowed, I got some people not writing anything down. I get it, you're tired from break. So am I. I moved 6 yards of topsoil. Get over it, we're back at school. A yard of topsoil is, imagine a yard by a yard by a yard, a cube that is 1 yard by 1 yard by 1 yard. About yay big, right? Like a yard's like about half as tall as I am. 6 of those. Put in my backyard. I'm tired too. I get it. Smack yourself in the face, do some jumping jacks, whatever you need to do, wake up. We got math to do. We could divide by 2/5. And this is why, I'll get my own paper, I guess. I was going to steal your guys'. What's it say in the middle of your paper?
But because you can change flip, multiply the reciprocal.
So a lot of like math teachers with our little tricks, and maybe your teacher taught this to you last year, of like, it's not KFC. So right here on your homework paper, right, this is what a lot of teachers will use as like the trick of what's happening. We want to get rid of a number that is dividing. What we're used to, a number that's multiplying. We're used to saying, okay, divide by that number. But keep, change, flip says division by 2/5, division of a fraction. So a number divided by 2/5 you should be writing this down. Keep, change, flip. What do we keep? The first number. So guys, that hashtag symbol, that just means number, right? So we keep the first thing. But then, what do we change? And what would we change it to? Multiplication. But because we did that from division to multiplication, what do we also have to do? Flip that second number, the second thing there, which in this case is a fraction. Oh, so now we're multiplying by 5 halves. Guys, it's easier to just jump right to just multiply by the reciprocal. Why would we add the extra step of writing out divide by the fraction when we know multiply by the reciprocal works? So if you have a fraction in front of a number and you want to get back to just 1x, and guys, down here on your paper, if I was you, I would give yourself a little reminder, oh yeah, this is 10 tenths x. 500 over 2, or 250. That's how we solve it. Questions. We're going to do a couple more examples to make sure it's stuck, but then my plan is to give you homework time. All right, you're going to need your graph paper. If I give you 9 halves of x, or 2/7 of x, or negative 3/4 of x. Did I copy this page 3 times? Yeah, I'm actually prepared, right? All right, I'm going to write these a bit bigger because I know they're a little blurry up there. You're going to want these on your graph paper because then I'm going to walk around and be real heartbroken if I've asked like 5 times and you're still not doing it. 9 halves. How do we deal with that? Guys, I'm going to flip this around. Our brain does better if we write the x value on the left. So I'm going to do 2/7 x equals 12. I can flip an equation around. It doesn't matter. And negative, you should put on top, not just leave hanging out front. Trust me, it'll make your life easier. Because now you have negative 3 over 4. Instead of when the negative's up front, you're like, wait, what? Like, are they both? No, if both were negative, it returned positive. Right? If both were negative, that's actually positive. So, guys, give the negative to the numerator. Makes your life easier. All right, try these out with your partners. Use those reciprocals. You might not need that number line. I just have it there so I can show you something. But you might not need that. How do we use reciprocal or reflip? Ooh, you could put that on your paper. Where we have written reciprocal, you could write refliprocal. So I'm going to do that. Refliprocal. You should be talking with a partner. Unless you're all just so good you don't need to talk with partners. So leave yourself space. Like this is great because then we can work down. How you stack all these on top of each other. We can't really leave yourself space. So I would you can leave those there, but I would write them across, kind of like what Jack did. So you've got space to then below show what you did. Hey guys, when you're taking notes, leave space to like show what you did. You want to make sure you write it on both sides, right? So don't just show it on the left side, show it over here also, and you're going to put that 27 over top of 1. If you got a whole number, make it a fraction by putting it over 1. You can do that too. Break it up into 2 steps. I love that. And actually, I'm going to copy my screen. I'm going to show that. You don't have to take the shortcut. And guys, sometimes the shortcut through the deep dark woods is not the best idea. What? I don't know. Just like a fairy tale reference.
Into the woods?
I loved that play.
I did too. I was watching on the drive to Pittsburgh.
Sometimes the shortcut, like, you never have to take a shortcut. I mean, sometimes you might want to. My shoulder's itchy. That's weird, but whatever. We're all humans. So, Jackson, I want you to tell us how you did that first one, because I love what you did.
I times 9 by 2.
Careful, you times 9 halves.
5.
So, guys, as I'm walking around, why did Jackson multiply by 2? What is he undoing? The division by 2. You do not have to do everything at the same time, but since Jackson just did times 2, it only wipes out the divide by 2. What do we still have? We still have 9x equal to, what's 27 times 2? 40, 50, 54. And now, what could I do to undo that 9?
Divide by 9.
It's multiplying. We can divide. So if you want to break these into 2 different steps, you can. You can take it one step at, sorry, crap, wrote the wrong number. What should I be dividing by here?
9.
The number you want to get rid of, right? So the number we want to get rid of is 9. We're going to divide by 9. 54 divided by 9?
6.
Anybody have any questions on that first one? Now, if we did the reciprocal method, that's the wrong stack of cards. Matt, what would the reciprocal of 9 halves be? Or the refliprocal? To what? It's weird to say 2 ninths, right? So 2 ninths. So we would multiply by 2 on top. 9. So I would just do the multiplication. Wait a minute. What's 27 times 2? 54. Isn't this the same thing Jackson just had us do? It's the same. You took a different route, but you really are going to the same place. All right, so let's move on to the second one since we already know the answer to the first one there. Ezekiel, what do we do with this 2/7 x? Yeah, the second one.
Well, I kind of used the number line.
Yeah, we totally could. If I'm going to use a number line, do you want to talk me through how I draw it?
So what do you mean, like, draw it?
Well, you said you used a number line.
You mean, like, how I marked it up?
Yeah.
Oh, so first I did that. And then I divided that by
Hold on.
2.
3, 4, 5, 6. So wait, I only need this much of the number line to be 2 sevens. Right? So guys, if you want to visually do this, 2 out of 7 means my number line has 7 pieces to it. So we would stop here, which actually I'm going to make that like black or something. Because I'm going to cross out the rest of the number line that I don't need. Right? Because that's 7 chunks. 1, 2, 3, 4, 5, 6, 7. Yeah, so the rest of this we would not need. It's gone. All right, go ahead.
And then I divided the 12 by 2 so I can see how much is 1.
So how much was that?
6.
So that's 6. And then what'd you do?
And then I times the 6 by 7.
So then we times it by 7. To go the 2, 3, 4, 5, 6, 7. So what is 6 times 7?
42.
42. Now, if we were to go the reciprocal route, Donna, what's our reciprocal of 2 sevens?
Juliet Garrett, please come to the Perry office. Juliet Garrett, please come to the Perry office.
If we go the reciprocal route, Donna's saying the reciprocal was, say it a little louder. Yeah, 7/2. And guys, we know these cancel. You don't even have to do anything over here. I mean, you just have to write X. That's it. But we have to do this here. Now, hold on. What did Ezekiel do first? Divided by 2, right? Hey, look, division by 2. And then what did Ezekiel do? Multiply by 7. Hey, look, multiply by... It's the same! Guys, do whatever you want. It's all the same. Whatever works for your brain. So what's 12 times 7? 70, 80, 84. Divided by 2? And we get that same answer. You guys need more time on the third one, or are we good? Because there's not very many cards left. You know, if you haven't been called, you're probably coming up. Like, your odds are going up. That was Donna. So your card.
Probability.
All right, Kamal, talk me through the third one then. What are we going to do to deal with this negative 3/4? Yeah, I mean, talk me through what makes sense to you. I don't want you to pick something you don't like. Okay, and if we take the reciprocal way, he says, we can put the negative 3 on bottom to cancel out the fact that it was on top. We can put the 4 on top to cancel out the fact that it was on the bottom. Before you do math. Guys, I know, the math teacher's saying, don't do math yet. What's a positive times a negative? In your answer space, before you do math, write the negative. Because you will forget it. That's one of the biggest trap doors, is you're going to start doing the math because you've got a couple steps to do, and you forget about the sign. But now that we took the sign already, we can ignore it. So this we can just think about as 3. Because we already took the sign. We know the answer is going to be negative. What's 21 times 4? Hey guys. Here's another secret shortcut. You don't have to take if you don't want to. What we just saw over the past 2 slides is you can do whatever order you want. Ezekiel divided first, then multiplied. Right? Jackson multiplied first, then divided. What if I divide first? What's 21 divided by 3? 7. This feels easier because the number just got smaller. 21 divided by 3 is 7. Now that times 4? 28. Or 21 times 4 is 84. Divide that by 3 because I don't know what 84 divided by 3 is. I might need to go get my calculator to do this. This feels tougher. I like Ezekiel's method of dividing first. When we set this up, you decide what you do first. If you divide first, you can get smaller. We could also do this on the number line. Right? 3 out of a total 4. Now we know we've got a negative involved here. But 3 out of the 4 was 21. What will but you got to figure out how to get the negative involved in there. That's why the number line is a bit tough here, like to do the number line technique. You have the last 5 minutes to work on homework. If you did not turn in 711 or 712 last week, you should probably do that since they're going in math today. Hey, within the next few weeks, just 'cause I don't want you guys to be upset, but well, if I had known, there will be times when if you're caught up on work, you get to watch a movie. If you're not, go to this other room and work on work. So realize we have 37 days of school left. We gotta get finished up with stuff because I don't want to be here over summer. I don't know about you, but I don't want to be here. If you want some help on 46, I'm going to jot down a couple things if you want to look up here and see what I'm writing down. What's up?
Can you help me? Some 45? Like, I figured out one way to do it, but I do not know the other way to do it.
Nope. Give your brain some time, because I'm going to do 46, and then it's going to be almost time to leave. If you give yourself some time to think, I bet you'll figure it out. That's why I'm not helping you right now. You got plenty of time. It's not due till Friday. Come back if you seriously can't figure it out. A dwarf lemon tree, I would not call DLT. I would just call D. Why would you give multiple letters when one does the trick? The semi-dwarf, S. The full size, F. Right, so if we're thinking about 46 and how to start this, they've told us about 3 things. Together. This feels a lot like those like bridge or buildings or bugs, all those together problems we've done. Together, okay, the D, the S, and the F, that should be a plus sign, equal 27. Now, I can't figure anything out if I'm using 3 variables over here. Anyone know a step I could go in the right direction? Sophie, you're right here in front of my face.
Well, it grew 3 times as much as the S, so F equals S times, 3S.
Sophie's saying this tells us F is 3S. So beneath the F, we could write 3 times S. Now wait, what about, so we still have D and we still have S. Do I want to drop both of those down? Somebody not Sophie, somebody else help me. Donna? The dwarf lemon tree only grew half as much as the semi. So the dwarf is half of S.
S is S.
And S is just S. Thank you, Sophia. Now be careful when I add these up. How many S do I have in total? 4.5, right? So I'm not going to finish this problem for you, but you could either turn that into improper and just do the fraction reciprocal method, or you could turn that into a decimal if you really want. Like, what's 4.5 as a decimal? 4.5, right? So, like, you could turn that into a decimal and use it as a decimal, or you could make it improper. Either way, have a great day, guys.
I don't know why I wrote it.
I don't know.
But I kept my signature
Sweet.
and all the
Sweet. Sweet.
except for everyone.
So let's get this one done.
1 and then 2 and 3.
I'm checking that there's nothing on the no-name board. Because it looks like you just got that today.
What?
No, nothing from Chapter 7, no-name.
No, I didn't just get this.
Oh,
I have
you were back there looking for something, weren't you? Or maybe I'm mixing people up.
No, that was a while ago. I was